Video focuses on the application problem with the quadratic function. We're going to focus on the vertex and the x-intercepts and what do they mean with the word problem. So here's what we give you. We give you a baseball player hits a ball towards the outfield. The height h of the ball in feet is modeled by this function. And where t is the time in seconds. So what I've done is I made in a coordinate. Here is my traditional y-axis, and here is my traditional x-axis. And in the word problem, this axis represents my time, my t, in seconds. And then this axis over here is my height in h, and the units is feet. So imagine this ball going up in the air and then it comes back down. So this is our ball traveling through the air. There are a few questions that we want to answer in regards to the traveling of this ball. Question 1. What will be the time that'll be at its maximum height? So if we look at this picture, it's a parabola. It opens down. Here is my maximum height that this ball could be at. So we're looking for the vertex. In this case, we want to know the time. So if here is my x-axis traditionally, this is my time. How do I find it? If you remember, to find the vertex of a problem, to find the x piece, we take opposite of b over 2a. So now we're going to go up into the equation. And our equation is h of t equals negative 16 t squared plus 22t plus 3. We're only going to care about our a term, which is negative 16, and our b term, which is 22 for now. So we're going to substitute those two numbers in, our a and our b, into this equation. So opposite of b is negative 22, 2 times a, which is negative 16. So negative 22, negative 32, negative divided by a negative is a positive. And then you can reduce that down by a half, so 11/16. So that's our time. As a fraction, it would be 0.6875 of a second. So a little over a half of a second, that the time would be that the ball will be at its maximum height. The second part of the question says is, what will be its maximum height? What will be the maximum height? Hint, it's the y of the vertex. So if you remember, to find the y of the vertex, you evaluate the function. So our function that we're evaluating is 0.6875. And now we're subbing it in to this function right up here in the blue. So you're going to want to use your calculator. Okay, maybe I'll write down this function first. h of t equals negative 16 t squared plus 22t plus 3. We want to find the maximum height. So we found the maximum x value, which is the time, of 0.6875 of a second. Substitute that in for t. And now you do PEMDAS. When you do PEMDAS, you do your exponent first. Now I'll do my multiplication. And then do our addition and subtraction. So the maximum height will be at 10.56 feet. Question C, the new part. If no one catches the ball, how long will it stay in the air before it touches back to the ground? Hint, x-intercept. We really don't care about this x-intercept. We want to know this one right here. So if you remember, how you find x-intercepts is you set the function equal to 0 and you solve for x. And you try and factor it. Now, this problem is not very nice, so we're going to leave it alone for now, and we'll come back to it at a later date. You want to use the quadratic formula. You probably remember this from Algebra 1, but we're going to reteach it to you in this class, so just hold off on it, but that's what this concept is talking about. If no one catches the ball, how long will it be in the air? What is the time before it hits back at the ground? So here's our parabola. It comes back up. What is that number right there for time? And there are two x-intercepts right here and right there. So again, we will come back to this problem at a later date, introducing you to solve this with the quadratic formula.